Okay, so we have a summation of logs, and we need to show that this is equal to that. So I guess this summation can be written as ln p to the power 1 plus p to the power 2 That's what this summation actually means. And I guess you could then rewrite this with the powers as coefficients. So you've got ln p plus 2 ln p plus 3 ln p, 11 ln p. So if you take log p as a common factor, you'll have something like this. And this is actually an arithmetic progression with the first term 1, the 11th term 11, and the difference 1. So this can actually be written as 11 times 1 plus 11 over 2. So that's something like n into a plus, or first term plus nth term over 2. So there's a formula for the nth, sum of the n terms. So that'll give you that. So 12 over 2 is 6. 6 times 11 is 66. So you can write that as 66 log p. So I guess that means that k is 66. So that's the first part. The second part of the question says, show that that is equal to that. So it's similar, but not exactly the same. So what we showed previously was this. So let's copy that and keep it handy. This is what we showed previously. And we can probably use this result to do this. So whenever you see an 8, you should be thinking 2 cubed. And they've got a 2 here, so it's likely that that 8 is going to turn into a 2 cubed. And when you've got a product inside a log, you can write that as the sum of 2 logs. So log a plus b is, log ab is log a plus log b. So we can probably write this as the summation of log 8 plus log p to the n. And you can therefore write that as another summation. And we've just shown that this summation is equal to k ln p, or 66 ln p. So it's the summation of log 8 plus, 66 ln p. And the summation here is for n equals 1 to 11. Now notice log 8 is a constant, and you're adding it to itself 11 times. So that's the same as saying 11 times log 8. So that's just 11 times ln 8. and then you're adding 66 log p. So if you, as I said, replace log 8 with log 2 cubed, you can then multiply this by the coefficient. So you've got 33 log 2 plus 33 times 2 log p. So I rewrote the 66 as 33 times 2 so that I can get this up there, and then you've got 33 common, because the question does suggest that we need a 33 and a 2, or a power 2. So I can write this as 33 log 2 plus 33 log p, and the plus suggests you can then multiply. So it's 33 ln 2 plus ln p, which is, oh sorry, that 2 becomes the power, doesn't it? So p squared, which is 33 ln 2p squared. So you multiply these here. So that's what they're asking for, and that's the final answer, I think. Question goes on and says, hence, so using what we've just found, find the values of p for which this is negative. So when they say hence, it means use what we just found. Now we just found that this is equal to that. So the question is, when is this less than 0? Well, 33 is positive. Then you've got a log. So when is the log negative? A log is only negative when the argument is less than 1. So you know what the sketch of log looks like. Sketch of log looks like this. So log of 1 is 0, and log will be negative for x less than 1. So if this is log x, we can say log x is less than 0 for x less than 1. So here it's the same thing. We can say ln 2p squared is less than 0 for 2p squared less than 1. So p will be less than 1 over root 2. Now I won't say plus or minus root 2 because p has to be positive because it's a log, and I think they probably specified that in the question. If I go to the top, they said p is a positive constant, right? So there's no point saying p is negative, so it's positive. So the full answer will be something like p element of r and p less than 1 over root 2. So these values, any value less than 1 over root 2 will give you this less than 0. And this is this summation. So that's how I would answer that question.